Today we will be studying about the forward propagation in neural networks. That is how the forward computations take place. As a recap, we have seen the definition of a feed-forward network, where it is a mapping from y equal to f function on x inputs and w is the weights, and it learns the parameters w for best function approximation. These are some activation functions which we have spoken about in a previous video. Today we will be working with the sigmoid function, and this is a general representation of an MLP or multi-layer perceptron, where we have input layer, one or more hidden layers, and the output layer. The working of a single neuron we have seen with the sigmoid function, that the inputs pass through the weights, and this is the summation part of the neuron which is computed here, and then the output of this neuron, which is the input or the summation, passed through an activation function, the sigmoid function, and this gets input to the next layer. And WIJL we defined as the weight for the link from node I of layer L to node J of the next layer, IJL. Okay, so now we are going to do the computations for node 1 of layer 3. This one, node 1, this suffix or the subscript Z1 3. So layer 3 and Z1 is the node 1. So how do we get the value of Z1 3? It is coming from A02, which is the bias input of layer 2, passed through W01 because it is connecting 0 to 1. So W01 layer 2. So this is the first component, W01 superscript 2 and A0 superscript 2. Then the next one comes from here, A12 through W112, this one, and the last is A22 through W21, which is this. So the computation of to this node, the input to this node is computed from the inputs of the previous 3 nodes and through the connecting weights. So this is how we get the Z13 of node 1 layer 3. Now we look at the computations up to the output. So Z2 is W1 transpose into X. So this is the layer to the different Zs. Okay, Z1, layer 2, Z22 and Z3. So we are looking at it as a in the vector or matrix form. A's are the outputs of the previous layer. And W1, it is this layer 1 weights. Okay. So Z22 is computed as the transpose of W1 into X. This is to match the dimensions. See, we have written here the transpose is required for the computation to be done, mathematical computation. Now X is also A1 because this is the input X, and that comes out as A1 because these are linear activation nodes. Then A2 is nothing but the G applied to Z2. Z3 is W2 transpose into A2. Then we are going on from one node to the other, from beginning X, then A1 to Z2, A2, Z3, A3, and finally is our output node. A3 is GZ3 and Z4 is W3 transpose into A3. HWX or the output is A4, which is GZ4. So here we are showing the forward computations written in the matrix format. So here we see the W2 matrix, which is this matrix of layer 2, it is the dimension is 3 cross 2, because we are having these 3 nodes here and 2 nodes of the next layer. So 3 cross 2. So W012, which is this one, W022, which is this one, this would be W02, and so on. So we have 3 cross 2, and A2 is the outputs here, A02, A12, A22. These will become the inputs to the next layer. And Z3 of layer 2, we have only 2 nodes here, so Z13, Z23. Okay, so this is the Z. So when we take the transpose of W2, we get a 2 cross 3 matrix. This multiplied by our 3 cross 1A here, we get the required 2 cross 1 Z matrix, Z vector. Okay, Z13, Z23. So this is what we wanted to illustrate about the forward computations. So we are seeing here that at each layer, the inputs are from the output of the previous layer. So the hidden layers are taking their own representation. So in neural network, it is learning its own features for the final computations. In between features, intermediate features are being computed. From the input layer, we get the hidden layer and another hidden layer maybe, and then the output. So the intermediate features, these are the learning of features for the final computation. So I hope the forward computations are now clear to you. So thank you. Thanks for watching.